Double-ended queue. A double-ended queue, or a DEQ, is a variation of the basic queue that we have seen earlier. All the properties of the basic queue hold, as well as a few additional properties. Now, if you remember, in a basic queue, all additions have to be made from the end called the rear, and all deletions have to be made from the end called the front. In a double-ended queue, additions can be made from both the rear and the front. Similarly, deletions can be made from both the rear and the front. So let me explain this with an example. Let's consider a queue. I'm writing down the indexes. Let's say that the status of the queue was this. When this is the status of the queue, the front will be at index 1, the rear will be at index 2. As I said before, a double-ended queue can have 4 operations: add from the front, add from the rear, delete from the front, delete from the rear. Let's look at how each of these operations work. First, I'm going to take add from the rear. So the first element I want to add at the rear, for example, is 5. When I want to add from the rear in this existing queue, this means I want to add at this end. So this means I want to add an element to this block. So how must I do that? Finally, we want a queue which looks like this. So the way to add at the rear is to change the index of the rear from 2 to 3 and then add the element 5 to the index of the rear. So front is equal to 1, rear is equal to 3. So what is the operation that we have done here? We have done rear plus plus. So now let's take a look at how to delete from the rear. So now when we delete from the rear in this queue, we will like to delete the element which is at the index of the rear. So we want to delete element number 5 at index number 3. So finally we want a queue which looks something like this. When we do this, front remains 1, rear becomes 2. So what we have done is, we have decremented the rear by 1 so that the queue no longer keeps track of that element. So the operation we do here is rear minus minus. Let's look at the third operation that we can do for this queue. Let's say I want to add the element 5 to the front of the queue. So if this is my existing queue, I want to add an element to this end. So I will add that element to this block over here. So finally, I want my queue to look something like this. So in this case, my front is equal to 0 and my rear is equal to 2. As you can see, when I added an element to the front, I need to decrement the front by 1, thereby making front equal to 0, and then add the element 5 to the index of the array, which is equal to front. So 5 is being added to the index equal to front, which is equal to 0. 5 is being added to array of index 0. So what is the operation we do here? We do front minus minus. Let's look at the fourth operation, which is delete from the front. When we delete from the front, and this is our existing queue, we want to delete the element 5 at index 0. To do that, we must move the front to index 1. So finally, I want a queue which looks like this. So what I am doing here is, I'm going to increment front by 1 so that the queue no longer keeps track of the 0th element. So in this case, the operation I am performing is front plus plus. Now, to this queue, let me say I am going to perform 2 more operations. I'm going to delete from the front. So when I do that, this function will give rise to a queue which looks like this. Where front is equal to 2 and rear is equal to 2. Now, to this queue, if I delete from the rear, I'm going to get a queue which looks something like this. Where front is equal to 2, rear is equal to 1. Now essentially, when the front surpasses the rear, the front becomes greater to the rear, then we know that the queue has become empty. Now we don't want a situation where the front is greater than the rear. So whenever we come across a situation like this, which makes the queue empty, we will not keep the front and rear the values that they are, because we don't want to continue a queue which has the front greater than the rear. So what we are going to do at a stage like this is, essentially the queue is empty. So we are going to reset the front and the rear back to its original values. So when the queue was initially created, the front and the rear are both set to -1, as shown in the previous videos. So when the queue is empty like this, we are going to reset the front and the rear to -1. So this 2 will become -1, this 1 will become -1. So why are we doing this? Once again, I'll repeat. We don't want to continue filling up or deleting from a queue in which the front is greater than the rear. We can see that when the front is greater than the rear, that the queue is empty. So instead of continuing with an empty queue with the front being greater than the rear, we are going to reset the pointers of the front and the rear to its original values, that is -1 and -1. In this case as well, we have an empty queue. And so we can continue using the queue by resetting the pointers to its original values. If you want to know why we are not going to use a queue in which front is greater than rear, it's because there will be a wastage of space. So if this is my queue and I'm going to continue with this queue, let's say I'm going to add in the front, I will add at position 3. If I want to add from the rear, I will add at position 0. The positions of 1 and 2 are completely wasted. So this is why we don't want to continue with a queue in which front is greater than rear, because there will be elements of the array which will be entirely unused. So we are going to reset the front to -1, reset the rear to -1. Same, the queue is going to be empty as well. And we can continue using the queue after we have reset it. So now that we know how the 4 operations of a double-ended queue work, let's look at how we are going to program these.